Hey guys, what's up? Welcome back to my math videos. Today I'm going to be explaining how to solve problem number 3 on the 2004 AP Calc BC FRQ. This problem is primarily concerned with vectors, which relate x and y coordinates to time. The problem reads, an object moving along a curve in the xy plane has a position x of t, y of t at time t is greater than or equal to 0, with dx dt equaling 3 plus cosine of t squared. The derivative dy dt is not explicitly given. At time t equals 2, the object is at position 1, 8. First, it's important to identify what are the most important givens in this problem. For here, it would be the dx dt equation, which will come in useful in our problem. The initial position of the object is also extremely important, not necessarily initial, but having the position at t equals 2 offers us a good reference point for our question. For part A, we're asked to find the x-coordinate of the position of the object at time t equals 4. We know from Calc AB that by taking the integral of the rate, we're able to find the net change of the particle over that allotted period of time. Since we know the particle's position at t equals 2, we only have to take this integral from t equals 2 to t equals 4 to find the distance it traveled in that time. If we add that to the initial value of x at t equals 2, we can find its position at t equals 4. So here I've put that idea into equation form. So the position of the object at t equals 4 is equal to the position of object at t equals 2 plus the net change of the position of the object from t equals 2 to t equals 4. And we find that net change by taking the integral of the rate, which is given to us earlier in the problem. This FRQ is on the calculator portion of the test, so we are allowed to use our calculator to evaluate this kind of nasty integral that we wouldn't be able to evaluate otherwise. So evaluating this nasty integral, we get that the x-coordinate of the object at time t equals 4 is 7.132. In this problem, we earn a point for writing the integral of the rate to find the change of the position of the particle, and then we get a point for utilizing the initial condition, and then we get a point for correctly putting it into our calculator and achieving the correct answer. So for part B, we are asked at time t equals 2, the value of dy dt equals -7. Write an equation for the line tangent to the curve at the point x of 2, y of 2. So we know for vector problems, the way to find the derivative is by taking the derivative of the y value and relating that to the derivative of the x value. So you just divide to do that, and it's pretty simple. So for this problem, we need to begin by finding the derivative at t equals 2. So for this problem, we are given that at t equals 2, the value of dy dt equals -7. So we can plug that into the top of the derivative equation. And then we also already know the equation for dx dt that we can use any time to plug that into. So at time t equals 2, dx dt equals 3 plus cosine of 4. Now, evaluating this with your calculator, you're going to get -2.983 for the value of dy dx. So finally, to put this all into the tangent equation in point-slope form, which it doesn't ask for, but that's just the easiest considering that we are given the position of the particle at t equals 2, we're simply going to do y minus 8 equals the derivative, which is 2.983, times x minus 1. And there we have it, that's our tangent line. Correctly solving this problem earns you 2 points, 1 for correctly evaluating dy dx, and 1 for putting the equation together. Now for part C, we're asked to find the speed of the object at time t equals 2. Now, we know for vectors, the formula for speed is the square root of the derivative of x in respect to t squared plus the derivative of y in respect to t squared. And you can see this kind of makes sense because it's like if you're doing the Pythagorean theorem and, here was your change in x and here was your change in y, and then, squaring those, adding them together, and then taking the root of that is kind of like your speed or your overall change. So now we just need to plug in 2 for t, and you might be asking yourself, we don't have the derivative dy dt, it's not explicitly given. However, we know from part B that at time t equals 2, the derivative of y is -7, so we can use that in this equation. Additionally, since we have the formula for dx dt, we can find x prime of 2 using that formula. So therefore, we know dy dt equals -7 and dx dt equals 3 plus cosine of 4. So now it's just a matter of plugging those values into our equation for speed and evaluating using your calculator to find that the speed of the object at time t equals 2 equals 7.382. And this problem only awards 1 point for the answer. Now for part D, they tell us for t is greater than or equal to 3, the line tangent to the curve at x of t, y of t has a slope of 2t plus 1. Find the acceleration vector of the object at t equals 4. So the acceleration vector is x double prime of t, y double prime of t. So to begin this problem, we'll start by finding x double prime of t, which is fairly simple considering that we already have x prime of t. So for this, we just take the derivative of x prime of t and use a little chain rule from AB and find that x double prime of t equals, x double prime of t here, equals -2t sine t squared. And now using your calculator to plug in t equals 2 for this double prime again, you find that x double prime of 2 equals 2.303. Now we have to find y double prime of t. This may seem a little tricky since we don't have y prime of t given to us, but if we use an identity kind of given in this problem, we can find it. So we know that dy dx equals dy over dt over dx over dt. So in this problem, we are kind of given our dy dx, since for everything greater than t equals t is greater than or equal to 3, the line tangent to the curve has a slope of 2t plus 1. And we already know the equation for x prime of t. So plugging this in, you can see that we have 2t plus 1 equals dy dt over dx dt, which is 3 plus cosine t squared. And both of these were given in the problem. So evaluating this, we can find that dy over dt equals 2t plus 1 times 3 plus cosine of t squared. Now, finding the derivative of this to find y double prime of t may seem a little difficult, but if you have a good calculator, this can actually be pretty simple. I can show you how to do it on the TI Nspire. You go to Menu, select Calculus, select Numerical Derivative at a Point, choose your variable. For this, we'll just have x. The value we're evaluating at 2, and its first derivative, and you just say, okay. And so now you can just plug in your equation that you have here for dy over dt to evaluate the double derivative. Now, using this method, I found that the second derivative is 24.813. So now we can go and we can create our acceleration vector, which would be 2.303, 24.813. And there you have it. So points are earned on this problem for correctly evaluating x double prime of 4, for finding dy over dt, and for achieving your final answer. Thanks for watching. If you like this video, please leave a like and a comment suggesting what you want to see next. And if you need any additional practice with vector FRQs or vector multiple choice problems, please visit the sites I link in the description below to seek additional help. Thank you.